Okay, so welcome back to part 3 of acceleration and velocity. Again, most of this is just a good review from us from calculus from last year. So, question number 2. It says the position particle is given by this function right here. Now, we should recognize this right away. Okay, we got this sine 2t, cosine 2t, which in pre-cal we said that was a circle. But remember, z is changing as well, so it's a circle, but it's increasing in values in z. So it's going to make a circle in the xy plane, like a projection will be a circle, but because t is changing, it's going up the z-axis, and this is going to be our spiral of death, or our helix model right there. All right, so you want to recognize that. So the first question says to find the velocity vector. Well, that is super easy to do. We know that the velocity vector is just r prime of t, and that is just going to give us, chain rule, 2 cosine 2t. Remember when chain rule last year was really hard? Yeah. Negative 2 sine 2t, and of course that just becomes 2t. Alright, the next question says find the speed of the particle at 2. So how do we find speed? Again, this comes from pre-cal, or in calculus at BC. We talked about this last year as well. It is the magnitude of your velocity vector. So to get speed at 2, we want the magnitude of the velocity vector at 2. And we already have that, so we can do this really quick. This just becomes the square root of, get the magnitude, this becomes 4 cosine squared, plug the 2 in, of 4. Let me zoom in here a little bit so you can see a little bit better. Plus 4 sine squared of 4 plus 4t squared. Now, and again, don't forget t squared. You're going to plug in, of course, your 2 there, so that we can just make that a 4 if we want to. Okay? All right. So let's see here. Now, don't leave your answer like this. Get used to this. Ready? This is what? That is just a circle. Sine cosine squared plus sine squared is 1, so that's just going to leave me with the square root of 4 plus 4 times 4, which is 16, and we get the square root of 20, and there is our speed at 2. Alright, part C says find the average speed. Oh no, this should sound kind of familiar for us, right? Average speed, that's right. Some people say it's their fave. Maybe not. Okay, so to remember to get average speed, right? How do we find speed? Okay, speed is the change in distance over your change in time. So we got the time, 0 to pi. That's pretty easy. But how do we get the change in distance? Well, we know change in distance is my integral. That is the distance between 0, between A and B, and the magnitude of our speed, r prime of t. So I'm giving you a little formula right here. dt over, divided by the change of time, b minus a. So again, if you recognize this is of course your average value formula. From BC last year, from calculus last year, this is just your average value formula. So let's see here. So this is going to go from 0 to pi, and the square root of, ready, magnitude of r prime, well we already got that, that just becomes 4 cosine squared of 2t plus 4 sine squared of 2t plus 4t squared. Don't forget your dt, your differential, and you divide that by pi minus 0. Now that looks really super ugly and nasty, but it does clean up pretty nicely. Let's take a look here, 0 to pi. The inside is not too bad. That just becomes 4 plus 4t squared dt divided by pi. And this will be your this will give you your average speed. Now this is not easy to integrate, so you'll definitely want a calculator for that one, or you can use, I think, your inverse trig stuff from last year. Alright, so I hope you enjoyed the video. We're not going to worry about part 3. I don't think that one turned out very nicely. You can try that one if you want to. But we'll see you in the next unit. Bye-bye.